Dividing mixed numbers using prime factorization. So the first thing we have to remember is that we can't directly divide mixed numbers. We have to first turn them into improper fractions. So in number 1 we would say 5 times 6, so 5 times 6 is 30, and 30 plus 5 is 35. So we get 35 over 6 divided by, and then we would say 2 times 3 is 6, plus 1 is 7. 7 over 3. Next step is to change it into its equivalent multiplication problem. So we keep it, change it, flip it. So it's 35 over 6, division changes to multiplication, and then you flip the second fraction. So we get 3 over 7. 35 is 5 times 7, and 5 and 7 are both prime. So 35 is 5 times 7, and then we've got our factor of 3 left. 6 is 2 times 3, and 2 and 3 are both prime, and then we've got our 7 left. Next thing is to cancel common factors. So I've got a 7 in the numerator and a 7 in the denominator. I also have a 3 in the numerator and a 3 in the denominator. So this gives me 5 over 2, because only the 5 and the 2 are left. Now we need to take this 5 over 2 and change it into a mixed number. So we can do it with division. This is really just 5 divided by 2. 2 goes into 5 2 times. 2 times 2 is 4. 5 minus 4 is 1. And that's my remainder, which is my numerator. So I get 2 and 1/2. Remember, when you're converting from an improper fraction to a mixed number, that if we had a denominator of 2 in our improper fraction, then we should also have a denominator of 2 in our answer. Problem number 2 is going to be somewhat more difficult. First off, we notice that there's a negative in one of our numbers. So we've got a positive divided by a negative. So different signs. Since we're dividing, we know that if they were the same sign, it'd be positive. If they're different signs, it's negative. So my answer, let me just kind of give myself a line for my answer. My answer will be negative. Now I have to convert both of these to improper fractions. So I'd say 12 times 5 is 60, plus 4 is 64, over 5. Divided by 2 times 5 is 10, plus 3 is 13, over 5. Next step is to turn it into an equivalent multiplication problem. So we've got 64 over 5. Division turns into multiplication. And then we flip the second fraction. 5 over 13. Now, we could break these down into prime factors, all of them, including the 64. The problem is, when I look at 64 and I look at 13, there isn't going to be a factor of 13 in 64. Right? 13 times something does not give us 64. So there's really no sense in breaking it down. When I carry the 64 and the 5 over from my numerators, and the 5 and the 13 over from my denominators, I can see that the only factors that are going to cancel are the 5's. This leaves me with 64 over 13. In order to convert 64 over 13 into a mixed number, I can take 64 and divide it by 13. Now I need to know how many times will 13 go into 64. And so you might need to do a little guess and check. For instance, say my first guess is maybe 5. 3 times 5 is 15. Carry the 1. 1 times 5 is 5, plus 1 is 6. And 65 is too large, right? I'm trying to get into 64. So that one's not going to work. But now I know that it's going to be 4. 3 times 4 is 12, carry the 1. 1 times 4 is 4, plus 1 is 5. So 13 goes into 64 4 times. 4 times 13 gives me 52, and then I subtract. 4 minus 2 is 2, 6 minus 5 is 1. So my remainder is 12. Remember, my remainder becomes my new numerator, so it's 4 and 12 over 13. So now when I go back to my answer line, I know my answer is negative, so it's negative 4 and 12/13.